Welcome to the January 2025 indoor meeting of the Raleigh Astronomy Club. I'm not going to bleed this slide, but if you're a guest, please put everything in chat that you would like to discuss or questions you may have. Please introduce yourself if you're a new member. And Sheila, I didn't ask you, but would you rather everybody stopped you and kind of stopped, or would you rather wait to the end for questions?
Mostly wait till the end, but if it's just really confusing, then feel free to address that confusion right then and there.
Okay, we'll wait till the end unless there's something rarely going on. All right, so I'm doing some upcoming events real quick, and then we'll go over them in more detail later. Steam night coming up, astronomy night at Joyner Park. We're going to do another stargazing at Cameron, North Carolina at the On Tap party. We're going to do another Willard in February. Morrisville Community Library is coming up in Morrisville, except I can't type. Math and Science Night. And finally, the statewide star party. We'll talk about these more later, but Mr. Chris wanted to say something about Astronomy Day, so I wanted to give him a second right here.
Okay, am I on?
No. Yes, you're on.
Yeah, yeah, got that little edge of sarcasm. So I expect nothing less from you, Bostic, so thank you.
Thank you.
uh, okay, yeah, so I just wanted to just go over, well, everybody knows what Astronomy Days is about. If I were to sales pitch it, it's one of the oldest, how can I say this, events in the country as far as coming to a public venue when it comes to astronomy being the subject matter. It originally started a long time ago as an event that was just put on by the Raleigh Astronomy Club at a different venue. I do know that Doug, he's here, and he gave me a little bit of input, but yeah, my memory isn't the best. So we did used to have it at it's either North Hills or South Hills. Yeah, there goes my memory again. And then we started a relationship with the museum, and the museum, being a bigger venue of exposure for the Wake County, gave us space to present this event that's been going on for several years now. And so there you go. So here we go for 2025. Of course, the hardest part is trying to get people to volunteer for these exhibits. I mean, that's a really bad way for me to really come out and say this, but we have several exhibits or booths that that the Royal Astronomy Club has exclusively at the museum for this. And again, it's on February 1st and 2nd. And there's the list for you. Solar Observing, Royal Astronomy Club table, and Ask the Astronomer, and astrophotography telescopes on display, exoplanets. If Earth were the size of the daily planet, which basically is all about just explaining how big the daily planet is, and if it were that big, how big the universe would be, all the way down to well, Earth itself, and then finally finding the North Star and other stars in the night sky, which is a good way of learning how the night sky works and using star charts and whatnot. I'm going to go ahead and share my screen.
If you didn't set it up ahead of time, you're not.
Okay. I don't know. I just sent a request. Let's see. I'll just pull it.
Naveen, you want to make him a co-host?
Yeah, sure. That's the easiest way.
Okay.
Done. Okay, thank you. Right. So, everybody see that? Okay,
Now we
so,
do.
okay, very good. So here's the list of exhibits and the volunteers who have dedicated themselves to filling in these shifts. And we have 3 shifts per day. And let me back up. I thank you very, very much for all those who have volunteered so far. And so beginning with solar observing, we're fairly okay with this exhibit, though we being out on the where we have the location of solar observing, have seen a lot more activity out there. So, given that, with that said, the afternoon of Saturday, it'd be nice to have some more, and then the morning and then the afternoon on Sunday, it'd be nice to have some more volunteers. This is solar observing, so again, make sure you have a proper solar filter. Make sure it's fully functional because solar observing can be dangerous if you're not careful. So, anyways, that's the status there. Raleigh Astronomy Club and Table Ask the Astronomer. What's that all about? Well, it's just all about letting the public know that there is a local club, Raleigh Astronomy Club, well, us, that people can learn about astronomy from the amateur astronomers here in the Triangle area. And everybody knows what Raleigh Astronomy Club is all about. We've been bringing the mantra of what amateur astronomy is all about to the Raleigh astronomy, or excuse me, to the Raleigh area since the late 70s. So been here for a while, and here you can see the slots here. We could use a lot of people for
Hey,
some help.
hey, Chris,
Yeah, what's up?
I'm going to interrupt you and say, I need you to bring this to an end, buddy.
Okay, all right, sorry. So yeah, anyway, there's the exhibit for Raleigh Astronomy Club table, so we can use a few more people on Saturday and definitely Sunday. Astrophotography, we're pretty good, except for maybe the last shift on Sunday. And telescopes on display, we deeply need a lot of help on that. So anybody who may have checked out a telescope from the Lunar program, this would be a great venue for you to volunteer and show off how a telescope works and whatnot. Finally, age, weight, and jumping on other planets. That is something we do not need volunteers for. We have Bob Lindsay here, so I'll get in touch with him to explain exactly what that's all about. Finally, of course, not finally, exoplanets. Brian Reeser can use some help there on Sunday and the end on Saturday. And if Earth were the size of the Daily Planet, Ron Monty runs that whole thing. He has some museum volunteers that will help out with that. Finding the North Star, which was spearheaded by Barton Meeks. So we can use some volunteers here on Saturday and middle shift on Sunday. And astronomy with binoculars. We don't really need any help for that because Frank Westmoreland, bless his heart, he can run that pretty much excuse me, so low. And then down here at the sky stories, don't just ignore that. But down here at the bottom, floaters. These are people who just go and help out where it is needed with all the other exhibits right here. So shift just denotes where you could use where we could use your help at other exhibits around the same time period. So here we go. So if you haven't volunteered already, please consider. Otherwise, hopefully it'll be a great year, and we'll see you on February 1st and 2nd. Thanks again for all those who have volunteered. All right, done, but Dana.
All right, quit sharing.
Okay.
You guys see my screen again?
Yes, sir.
Okay. So, Sheila, I looked up how to say your name 3 times today, so I'm going to try, but I am a Eastern North Carolina redneck. So, Sheila Kannappan researches galaxies, black holes, and cosmic structures as an emeritus professor at UNC Chapel Hill. In 2024, she launched a new phase of her career dedicated to pursuing and sharing celestial awe by spending 3 months eclipse and aurora chasing. Did I get anywhere close, Sheila?
Yeah, it's fine. My last name is Kannappan.
Okay, well, I tried. All right, I'm going to stop sharing my screen and let you share yours.
It's not letting me click optimize for video sharing. Something's changed about the setup. Dana, are you there?
Yeah, I'm here. I'm waiting. I was waiting for Naveen since he's recording.
Oh, okay.
Sorry
I don't
about
know,
that.
maybe something, the only thing that's changed is we're recording and streaming on Facebook, so maybe we just won't be able to optimize, unfortunately.
I hope
I-
that the videos work.
Yep, I hope so too.
Find out in a minute.
Mhm.
So my hope is that you can see the slide, but there's nothing blocking it.
We can see the slide. Nothing's blocking it.
Okay.
Yeah.
Excellent.
Yep, looks good.
Yeah, that toolbar gets in the way. Only on the presenter side.
Okay, great. Well, thank you everyone for coming. Thank you, Dana and Naveen, for inviting me. I'm super excited that some of my friends have joined the Raleigh Astronomy Club from as far away as Australia. So, and a few from Texas and elsewhere. So thank you so much for joining. I am going to be talking about auroras mostly, but this is part of a larger new phase of my career dedicated to truth and awe and writing and speaking and exploring truth and awe. So I am not giving you my UNC Chapel Hill.
It's unfortunate.
Sorry?
Oh, sorry.
Sorry? Is there a problem?
There's a problem that some of us don't know how to use our mute sometimes. That's all.
Oh,
Sorry
okay.
about that.
Okay, sorry. So I'm not giving you my UNC Chapel Hill email. I'm giving you Astro Awe Seeker because that is the dedicated email for my new phase of my career. I did just retire in the middle of last year. And I have a placeholder webpage where you'll be able to find all my slides, and any URL that I give you is in the slides and you can get it later. I will also give you a QR code at the end of this talk so that you'll be able to even get to this website. So in other words, you don't need to write anything down. So why awe? Well, I mean, of course, astronomers deal in awe, but there's more to it than that. As I started to understand some years ago when I learned about the science of awe, awe, it turns out, is one of our fundamental human emotions, just like happiness, anger, fear. Awe is the response that we have to things that stretch the limits of our minds. And it's both physical and psychological. So physical, you've probably experienced chills or goosebumps. Also, slowed heart rate is associated with awe states. On the psychic side, I'm actually even more interested that people feel, of course, wonder, but also humility and connectedness. And that means that as much as awe is at the heart of astronomy, it's also at the heart of our humanity and our ability to work together to kind of fix some of the mess we've made as humanity in this world through humility and connectedness, as well as stretching our minds. So I had quite the year of awe in 2024. I saw a total solar eclipse and at least 5 auroras, depending on how you want to count. And I'm going to share with you how that went. I have to say that aurora chasing is not technically astronomy, and I am not an expert on auroras. As I believe was mentioned, my research has been on galaxy evolution. So definitely something that I am appreciating as an amateur. And I, for many, many years, had a picture of an aurora on my wall. This is not the actual picture, but you can imagine me just wishing and hoping that I would ever see an aurora like the one that was framed on my wall, but it never actually happened. So the first thing that I experienced in terms of celestial awe was total solar eclipses. And the first one was in Madagascar when I got my PhD in 2001. I took a celebratory trip to the opposite side of the planet and got to see this sunset total solar eclipse. And then, like probably many of you, I traveled to South Carolina and saw the eclipse there in 2017. But it really wasn't until this past year in 2024 that I started to appreciate the details of the eclipse that produce that sense of awe, because I was starting to pay attention to the science of awe and also starting to understand how a purely factual understanding of an eclipse, if you string together the facts in the right way, you can see how there's actually something very powerfully spiritual in just the scientific facts strung together to kind of connect the dots with our human response to the eclipse. And so I gave this talk in Astronomer's Call to Worship when I was at the U Retreat Center in the Hill Country in Texas, seeing that total solar eclipse. And a couple of friends we met there are here today. So obviously the most well-known aspect of an eclipse that inspires awe is the corona, our amazing and fleeting view of this really ethereal, wispy thing. And of course, to our eyes, it does not look like this. This is a fantastic professional image of an eclipse that shows every tiny wisp, and you can even see the craters on the moon. So this is beyond human capability to see, but when we see it, we do have this sense of wonder at seeing the wispy corona, and that is the sun's crown. That's what the word comes from. It's from the Latin for wreath or crown, and it stretches out into space and it becomes the solar wind. So that solar wind, of course, this is a very compressed picture, but that solar wind extends all the way from the sun to the earth. And that's really, it is little pieces of sun flying off of the sun and coming and hitting us. The sun is gradually, through the solar wind, casting off its outer surface to come and impact the earth. And so while the sun is a god of life in terms of light and heat and so on, it is also a dangerous god because this solar wind can damage life. It's particles, it's material bits of sun. And so the Earth shields itself from the solar wind with its magnetosphere. These blue lines are the magnetic field lines of the Earth. There's a larger magnetic field, the interplanetary magnetic field, that the sun creates through the whole solar system. So this video, can you see the video? Is it moving, changing?
Yes.
Wonderful. Yeah, so this video is made by NASA. It's to simulate the solar wind. You can see at the surface, the corona, all those particles coming off, and you see it coming and impacting the magnetosphere. And the stretched out part of the magnetosphere is called the magnetotail. And you see as it goes further and further, it bends and stretches the magnetotail until suddenly lines of magnetic fields will come together and boom, connect. And now ionized particles from the sun are pouring down onto the earth and creating the aurora. And you can see the aurora is also a crown. It's a crown around the north and south poles. So our planet has answered with an echo of the solar crown that I see as sort of a scientific form of worship. It's to me very much akin to the ceiling of the Sistine Chapel, where you see the finger of God and the finger of Adam touching. And when I saw the total solar eclipse, I was in my mind imagining the sun's corona reaching out and touching the earth and creating that aurora, that circular crown. In fact, the crown aurora has been seen from the International Space Station. This is a beautiful view of it. And I have actually seen it, believe it or not. I saw the entire circular aurora around the magnetic North Pole when I was lucky enough to have a left side window seat on a transatlantic red-eye flight to Heathrow. And as I sat there glued to my nighttime view of the North Pole and those dancing lights around it, I did not sleep all night. It was so magical and so amazing. That said, the corona I have seen, the circular crown aurora I have seen, I still had never seen the thing I had hanging on my wall all those years because I had never seen an aurora from the ground. And they're very different. I'm not saying one is better or worse than the other, but it's a very different experience. When you see it from space, or at least when I saw it from an airplane, I could not see color. All I could see was the dancing light. Then came the aurora of May 11th, and we were in North Carolina. And as you can see, the max visibility line, even the possibly visible line, was stretching down to Raleigh. Can you see my cursor, by the way?
Yep.
Yes.
Okay, awesome. And so this is a photo someone took of the night sky somewhere in North Carolina that night, and they saw the red glow of the aurora. I don't know if they saw it with their naked eye. A few people claimed that they saw a hint of it with the naked eye, but the camera could certainly pick up the color. And that was really heartbreaking for me because my husband and I missed it. We were, yes, definitely heartbroken. However, we took it as a wake-up call. I had just decided to retire, and we thought, it's the year of solar maximum. We've got to do this. So northward, we needed to go someplace with better odds than North Carolina of seeing a aurora. Specifically, we went to Minnesota, and you see the geomagnetic pole here is a little bit towards North America from the rotational North Pole. And so this is the auroral circle when it's not, extended, but just on an ordinary night. This green represents the auroral circle, and it's around the magnetic North Pole, not rotational. So it does stretch down to the United States. You can see it there grazing around Minnesota. And so you are very lucky, those of you who live in North America, because you can see that living on the other side of the world, it doesn't get down so far into inhabited territory. So we spent 2 months in Minnesota, September and October. We had no tour, no plan, and no experience. So I'm here to tell you that without being an expert, you can succeed and you can have an amazing aurora chasing adventure. All right, so the left map here, these are all the places where we spent 1 or more nights in our aurora chasing adventures. And most of the nights were spent here in Minneapolis, but we did go all the way to the border of Canada and down into Iowa. Here, I have numbered all the places where we saw auroras. And the reason I said at least 5, there's an example here that you may or may not want to consider to be an aurora, but I'll tell you about it. And then there were multiple auroras in a single night in a couple of locations. These other locations where you don't see a number were places that we scoped out for possibly seeing the aurora. They would have been great viewing sites, but we didn't actually see an aurora from there. So the reason I've been hedgy about number 0 is that seeing an aurora, what most people mean by that is seeing an auroral substorm. And that substorm is when that stretched magnetotail snaps back and reconnects, and you get those ionized particles just pouring down. And then the aurora becomes dramatically enhanced. It dances around, it expands and stretches down further into North America and other parts of the world. But the auroral oval is actually always there. There's always magnetic field lines coming down around the magnetic North Pole. And so there's always an oval. And if you go far enough north, you will always, if there's not clouds, see something. So item 0 was that we actually saw off in the distance this gray glow here. And we saw that even before we saw number 1. So I'm showing you a picture of number 1 that has the red and green. This was our first real thing at Cass Lake near Bemidji, which is halfway up in Minnesota to the border. That was September 12th. But the night before that, we had seen just this because we were far enough north that we could look towards the North Pole. We went to a very, very dark location, and we could actually see just in the far, far distance kind of a flickering gray light. And that is not the location of any town. It's not light pollution. It was the kind of permanent auroral circle. Notice this says 3:30 a.m. It can get exhausting, aurora chasing. So it was too faint on that first aurora we saw to see the color by eye. So these red streaks and this green were captured by the camera. This is my husband taking pictures. This guy was just a local guy. He was totally unimpressed. He just fished. So when and where should you go to see the aurora? Well, first of all, when is now? It's the solar maximum. It has recently been declared maximum, but of course you don't really know exactly when the maximum is until you see things come back down. But right now things are just going gangbusters in terms of sunspots and solar flares. There were a ton of them on New Year's Eve and New Year's Day. It's exciting. You want to go when there's frequent clear skies. You don't want clouds, so fall. More night and less cold. So aurora chasing can be very cold. So we aimed for September, October to strike that compromise. Whoops, wrong way. Whoops. I don't know why it's not appearing. Okay, there we go. Nope. Oh, right, because I did want to say this first. I'm sorry. I wanted to give credit to the Aurora guy. Most of how we went from 0 to 60 in terms of knowing how to chase auroras was by reading this amazing free guide that he puts out. And the only price you pay to get this free guide is joining his mailing list, which is a very minimal, like he sends something maybe once a month, and it's a fantastic mailing list to be on. So I have nothing but good things to say about this guide to aurora chasing. All right, moving onward. So this is as much as we knew before reading the Aurora Guy's Guide. And beyond that, he added these things that we learned. He said, you want to go near an equinox. And turns out that at the 2 equinoxes, that is when you get the most auroral activity. And it has to do with the magnetic poles of the Earth being best aligned with the magnetic poles of the interplanetary magnetic field. In addition, he would advocate that you want to go when the moon phase is half full. And the reason for that, it's a compromise between how your eyes work. You have rods and cones in your eyes. The rods are the most sensitive part in low light. And so when you get dark adapted, that's your rods starting to pick up on very faint things. But the cones are basically going to sleep. Your cones wake up in bright light and they see color. So when you see an aurora, you want to see both the faint stuff and the color. So that is why the Aurora guy advocated for the half full moon. But actually, in our experience, I would say all moon phases are wonderful because in the new phase, you're going to see fainter. And in the full phase, you're going to see more color. So I think that ideally you just go for all of it. You also want to go when the aurora is closest to you. This is not obvious from this picture, but in the upper right, this is a screen capture from aurorasource.org. They give a visual of this auroral circle as it moves, and it does kind of stretch and rotate around over the course of the night. And you want to get out there when it's stretched out above your state. You know, if you're in Minnesota versus Washington state, it's going to be more stretched out at different times of the night to be actually on top of your location. Okay, somebody just put an arrow. Somebody named Andrew just put an arrow on my screen. Is it possible to get rid of that, Andrew? I don't know if that's going to persist. Yes, it's going to persist. Can somebody named Andrew please remove the annotation they put on my screen? Thank you. All right, so the final thing, of course, in terms of when, is you'd really like to know exactly when are these substorms going to happen. And I will come back to that. That is a very tricky question. All right, so the where. We had already figured out north and dark. That didn't take too much brain power. But our first thought about north and dark was that the northern wilderness of Minnesota would be great because it's international dark sky parks, it's boundary waters, total wilderness. It just seemed like, that would be perfect. And, we did head up there. So I showed you already number 1, that was the first aurora we saw in Bemidji, and we kept going north. So our home base was down here, the Red Thumbtack in Minneapolis. We kept going north past our first aurora all the way to the Canadian border, and we went to this little town, Arneson. And the way we chose our viewing locations was using this website. It's called lightpollutionmap.info. And you can see this has something called the Bortle scale, that you want to be where the faint aurora might be visible is green to blue and darker. And so you don't want to be in yellow, red, pink, or white, right? Well, so our first location was actually a bit higher on the Bortle scale. It was Bortle 4, whereas our second location was Bortle 2. So it should have been really dark. And like I said, this is, on the border with Canada is dark sky park kind of territory. But it turned out that actually it wasn't wildly different. And that's because when we were here at Cass Lake, the lights nearby were blocked by trees and other structures. So there was no immediate light in our eyes. Whereas when we went to Arneson, which was Bortle 2, there was actually a bright security light nearby that was in our field of view. So one of the things that we learned sort of the hard way was you really have to scope everything out in advance, because the light pollution map that you get online is not going to tell you where there might be high beams in your eyes, that kind of thing. So this is what we saw in Arneson, and it's 10:50 p.m. in this picture. And I want to point out that there's this concept. I'll just go back here. I crossed this out and I didn't mention it, magnetic midnight. There's this concept that you might want to look for the aurora at magnetic midnight. And that means when the auroral circle is most stretched down towards your location. Well, that is between 11 p.m. and 2 a.m. for Minnesota. And now I've shown you 2 auroras, neither of which were between 11 p.m. and 2 a.m. So I basically think that it's a bad idea to only go out between the hours of magnetic midnight. I think you should just be out there. All right, so this was the first time we saw an aurora reflected in the water, and the first time that we saw color just by eye, although it wasn't totally brilliant, but we could see the hint of color, and that was pretty exciting for us. The downside of this, of course, was that we had gone so far north that we were at the limits of civilization, and our dogs did not appreciate that we had barely enough dog food to make it back to Minneapolis, and they had to eat some cheap substitute product. So instead of going to the northern wilderness of Minnesota after that first foray, we decided what really made sense was a northward vista, such as the south shore of a lake, just not underneath any clouds and someplace dark. And it really didn't need to be so far north. We chose south shore of a lake for a few reasons. One is it's scenic for photography. You get those reflections. Another, often it's safe and near a bathroom because there will be fishing piers or boat docks, and there might be a little park or even a porta potty. And it's usually accessible on short notice, especially in Minnesota. You may know Minnesota is known as the land of 10,000 lakes. That might even be undercounting. There are so many lakes there, so many boat launches and fishing piers. And being on the South Shore, you always have a clear vista towards the north. The last piece of where is away from the clouds, and that is something you can only judge in real time. These are the websites we ended up using, and They were very effective. You cannot use the weather forecast, like when does the forecast say there might be clouds or rain, because that does not give you the geographical detail. We were truly chasing little holes between clouds often. We did get lucky, and I put lucky in quotes because this was not good for the locals. They were having a drought, but not having rain did mean that there was less cloudiness. But, there can be clouds without rain, and we had to drive as far as Iowa to dodge clouds. This location, where you see me sitting on a pier, was our absolute favorite aurora viewing location. It is in this corner over here, and you'll notice there's no number next to it. We did not ever get to see an aurora in our favorite aurora viewing site. It was only our favorite because it was so beautiful and dark and convenient. There were even chairs on the pier, and you see I took a picture of the reflection of the Big Dipper, but alas, it always had clouds when the auroras were coming. And we ended up racing to a random country road away from there. There were no clouds over here to see aurora number 3. And this is aurora number 3. And this one was absolutely the time that I felt like, okay, now I'm getting to see what I had on my wall all those years, because the colors were so brilliant. And why? Well, it was a nearly full moon. And you can tell because this is a 6-second, a 6-second exposure on a phone. This is just my Google Pixel 6, and the sky looks blue. It's night, it's 10:24 p.m., but the sky looks blue because it's a nearly full moon in 6 seconds of exposure. And that meant we could see the color so well. Absolutely beautiful. And again, 10:24 p.m., not between the hours of magnetic midnight. So the question of when will there be an aurora is really kind of akin to the question of when will there be a snowstorm? Except that, for those of us who are experiencing a snowstorm right now in the Raleigh-Durham area, we got a much better prediction than you'll ever get for an aurora. So aurora space weather prediction is very, very primitive compared to Earth weather prediction. The first warning you'll get is when there's either a medium or extreme, so those are called M or X class solar flare, and you can get alerts about those from either of these websites. The Aurora guy mentioned this one, but we ended up using spaceweatherlive.com because, well, first of all, it's free. It has more science information, and it also includes coronal holes and streams. I'm not going to talk about coronal holes and streams, but they represent another way you can get enhanced solar wind activity and enhanced auroral activity in addition to solar flares. So it's not the solar flare itself that creates the activity. As you saw, when there's a flare that's at the surface of the sun, that's just creating kind of a burst of solar wind. That burst of extra solar wind is called a coronal mass ejection. And the coronal mass ejection, or CME, is really what matters because that's what's going to hit the Earth. That's what's going to create a shock that pushes on the magnetosphere and pinches that magnetotail down until it connects and creates that cascade of particles. Also, there's that wild card equinox effect. It was September 22nd in 2024. So we saw a lot of auroras on either side of it, and that can enhance activity. So the way you get a sort of zeroth order forecast is to follow the NOAA website predictions. So they have a twice a day updated forecast that is for 3 days, and it's for the entire Earth. And what they do is they just tell you, is it going to be KP 5, 6, 7? Well, most of the time it's KP less than 5. 1, 2, 3, 4 is basically no activity. We came to see KP 5 as not really worth bothering with either. So KP 6 and higher, that is orange and red, is when there was moderate to high activity, and that was really what was worth chasing. I will just mention briefly that they have a kind of a second website that is their 3-day geomagnetic forecast as opposed to 3-day forecast. that was so confusing because you don't want the geomagnetic one because they're actually both geomagnetic, but the second one that I said you should not use is only updated once a day. So don't use that. Don't get confused by it like we were. All right, so that's just a heads up, but it's not the world's best prediction. And just to illustrate this, on September 15th, we woke up, we were in the city, we were in Minneapolis, to an X-class flare alert, and there was supposed to be a fast CME that was going to be a direct hit. That was actually such a great CME and so powerful in terms of the expected storming that it was in the news, like all the newspapers were covering it. But there were clouds everywhere. So we had to do a frantic search for, where could we go to dodge the clouds, depending on how they would evolve in real time. And NOAA was predicting that we would see that CME sometime late that same night, within 24 hours, it was going to come really fast because it was coming straight at us. Well, in fact, there was no CME all night. And although we kind of stayed up checking all the information, nothing was actually happening. The CME had not arrived. So finally, the next day, we were exhausted. So we took a nap in the afternoon because you're not going to see an aurora while the sun's up. And we woke up to an alert. So the actual aurora was late. The actual CME was late compared to the NOAA prediction. And as we frantically drove to try to get to a dark place, it kept rising. We get alerts. It was KP6, then KP7, then KP8. And we were speeding like crazy to escape the clouds and the lights and get to a rural vista, all for 15 minutes of magic. And that is the magic that I just showed you on that near full moon night. It was so brilliantly colored on that night that I was so overcome with awe that there were just tears prickling in my eyes. And I can't tell you how annoying it is to have tears obscuring your vision of a gorgeous aurora. Okay, so you might say, okay, but really, like, how can we get a better prediction than that? Because that's not even accurate to the day. All right, well, so the Aurora Guide's beginner guide taught us to pay attention to a few other things. First of all, Aurorasaurus, that has the moving oval, so you can see where it is. It's a model. It's not the actual oval, but it's a very carefully done real-time model. And also, you have social media reports. So somebody's tweeting, I see the aurora. You get to see where that's happening. And then also Space Weather Live has all these graphs of solar wind data that are super helpful. So there's the speed, the density, the magnetic field, and especially the Z component of the magnetic field. That's the vertical part of our Earth's magnetic field, which is what the interplanetary magnetic field would grab onto. The magnetic field in the Z direction is the single most critical thing to whether there's going to be an aurora. It is literally referred to as the on-off switch for the aurora. If BZ goes negative below -5 for 30 straight minutes, that's a good time to have your heads up, like literally. The way these graphs are read is they represent data from NASA and NOAA satellites. And on the right edge of the graph is the data that NASA and NOAA satellites have just measured. And that is way out in space. So it's still incoming to Earth. And it's going to take maybe 40 minutes to get to Earth. So this vertical line at Earth is stuff that was measured some 40 minutes or more ago, and that is now impacting Earth. So that means you get, 40 plus minutes of warning that stuff is incoming, and you can watch that BZ and see it go solidly negative for a stretch of time and realize something good is going to happen. But 40 minutes isn't necessarily enough time. If you're in the heart of Minneapolis, you are not going to get somewhere sufficiently dark in 40 minutes. So you have to be ready. The density will be more confusing. I've seen a number of places where people claim that the density rises when the CME arrives and the auroral activity gets good, but actually it both rises and falls because there's a shock front, and a shock front has the pre-shock and the post-shock. And as it's plowing through, you're going to get a sudden drop in density as well. And what we found is that the sudden drop in density was actually better correlated with when we were seeing the auroral activity. All of these graphs, however, are really only telling you that you have the right conditions for an aurora. They're not telling you that an aurora is actually happening, like that snap of the magnetotail and that sudden cascade of particles. They're not telling you about that. That's the substorm. So how can we know when the substorms are? So this is not in the beginner guide from the Aurora Guide, but the Aurora Guide does have a blog post about it. He calls it Advanced Aurora Chasing. And this ended up being our real go-to. And that's actually a pun intended, because these are the satellites called GOES. So there are two GOES satellites. They are geostationary. That means they hover over the east and west coasts of North America at all times. So they're rotating with the Earth. And they're magnetometers that are exactly identical. So they are just going to measure the exact same thing. If it's a quiet night, they're just going to measure as they pass through the magnetotail and out the other side. They just trace a sine wave. And so these red and blue lines would be just a simple sine wave with a delay, east versus west coast, if everything was quiet. But as the Aurora guy says, out in the field, this is the main thing he pays attention to. And the same thing became true for us, because when you see deviations from a sine wave, like this huge spike, where not only is it going way down lower than normal, but also the red and blue are completely lined up. There's not a delay between them. So that is the magnetotail stretching back, huge stretch back as it goes down, down, down. It's stretching, stretching, stretching. And when it suddenly snaps and you get reconnection, then it shoots back up, steeply back up. So those downward spikes are telling you, be ready, because as soon as this turns around, you're going to see a substorm over North America. And I apologize to my friend in Australia that I don't know what there is equivalently there. So we, after the fact, because we hadn't learned about this before we saw Aurora number 3, lined up our Aurora sighting with this graph, and we saw, wow, this was the deepest spike on that night. But we went home when it was over, and we were idiots. And actually, the Aurora guy says, I have seen many chasers quit early after seeing the Aurora at a standstill. It's exactly what we did, because as you can see, there were 3 more Auroras that night. I take a little consolation in the fact that we saw the biggest one. You see, we saw the deepest one, but still, it's a bummer that we didn't stay and see more. Another gotcha I want to mention is all Aurora chasing data, plots, everything is in universal time. And even though I'm an astronomer and I should know better, I got confused about this repeatedly. So 10 p.m. on September 16th, which is when we saw this beautiful sight, was 3 a.m. September 17th in universal time. And that's how I know how to line up this chart, but it's also critical to reading all those predictive graphs and understanding in real time what you're seeing. So that was September. Now comes October. And October came like with a bang out of the gate. On day 1, we had an X7 flare with a CME that was predicted to be a glancing blow on the Earth. And then on day 3, an X9 flare that was predicted to be an even better CME. So by October 3rd, we were camping at Mille-Lacs, one of the largest lakes and darkest spots in Minnesota, trying to catch the CME from the X7. The NOAA prediction was wrong. Nothing showed up. On day 4, we made a round trip down to Pills Park. That's our favorite aurora viewing location I showed you. Drove all the way down there, hung out for a while, drove back in the wee hours in the morning, exhausted because nothing happened. On October 5th, we went down there and we camped this time, so we actually got to sleep, but we kept checking the graphs, setting our alarms for every 30 minutes to see if something was happening. Never. not a blip. Finally, not just us, but everybody around the entire planet was getting fed up. And on Space Weather Live, there are all these chat groups, and everybody was just like, what happened? Where are these CMEs? They both should have arrived by now. Nothing has happened at all. They must have just missed Earth somehow. So on October 6th, we were just tired. And it was too late. When actually there was a little bit of activity. There was sort of a lower KP level. We saw it, but my dear husband was like, I think something's happening. And I was like, I think this is a false alarm. And by the time he convinced me we should get going, we missed it because, auroral substorms are brief. And then when we missed it, we just thought, okay, we can't do this anymore. We went home and went to sleep. We were so tired. So there was something that night, but we didn't get to see it. And then we thought, okay, what we missed was these dud CMEs that were supposed to be good, but what we missed on October 6th must have been them arriving late because, wow, it had been so many days. And so we went to, actually, I slept until past noon on October 7th because I was so exhausted after all that. And then finally sort of got dressed and got together enough in time to go out to dinner in downtown Minneapolis. And the evening of October 7th, we're sitting there having dinner at the middle of Minneapolis. Like we're not even in the pink, we're in the white. I mean, this is like flashlight shining in your eyes, light pollution. We're sitting there eating dinner, and I looked down at my phone. I was like, oh my God, it's happening. And we looked at everything, and we looked at the GOES magnetometers, and it was happening. It was crazy. There was no way we could get from there to someplace truly dark in the time available. So we went to this place called Elk Lake. We scoped it out in real time as we were driving. I mean, the person who wasn't driving found it. And this is it. It's like a slightly more greenish yellow within this mass of light pollution. And we got there in time to take photos nonstop from 10:20 to 11:43. That was at least 2 auroral substorms. And there were a lot of people there. Everybody was excited. But after 11:43, everything faded and got quiet, and the crowd left. And it was so cold. My feet were like icebergs. But GOES said stay. We saw it going down and down and down, and it looked like this was going to be the deepest spike of the night. So we stayed. And this is what suddenly appeared. And my husband said, get out of the car, come see this. And after this sawtooth, we saw the most amazing displays ever. And as it was roiling and swirling and raining down red and green, we were just spinning around. It was all around us. We were not looking north. We were looking in every direction and seeing the aurora. And at some point we realized it's exploding above us. And what that looks like, it's looks like an explosion above your head because you are looking miles up into the atmosphere. The effect is just like if you're at a train tracks and it's stretching off into the distance and it looks like those 2 tracks converge, but they're really parallel. And that's what's happening here. These are streaks of light from ionized particles that are falling down from so far up above us that they all seem to be coming from a vertex. But really, it's just that auroral rain of light from all those ionized particles. It's just absolutely stunning, so awe-inspiring. And it continued, and it just went on and reflecting in the lake. It was so gorgeous. And then, it started to get a little bit less, but it was these like gorgeous watercolors everywhere and still bright enough to reflect in the lake. And my husband took these videos So this is a 4-minute night mode exposure, but it's compressed into 1 second. So this gives you a sense of how it's swirling and roiling and raining. It's not how it appears to the eye, because although the camera is much more sensitive to color, your eye is much more sensitive to the real-time movement. And so our eyes were picking up much more fast dancing, changing lights than the camera possibly could. And, it just kept going. It was so amazing. And finally, at the end of the night, after 3 hours, at 12:24 a.m. was the last photo we took. After 3 hours that night, plus the previous 4 nights of exhausting failed aurora chasing, my driving was a little erratic. So apparently I took a really wide left turn, and I also had an out-of-state plate. And so, the little swirly lights started spinning, and this very nice police officer thought I might be a drunk driver or some other sort of criminal. But after running a few background checks on me, she bought my story that I was merely an exhausted aurora chaser, and she didn't give me a ticket, but instead allowed me to take a picture. So we thought, okay, that epic multi-day exhausting adventure couldn't possibly be topped. And then we got home next day, October 8th, and there was an X2 flare with a perfect CME. Dense, fast, headed straight to Earth. We had a little bit of leeway to figure out where to go, but there was no hope for Minnesota. There were clouds everywhere in Minnesota. So we decided we're going to have to go to Iowa. That was the nearest place that was clear. And that was a pretty substantial drive. That's as far south from Minneapolis as we had gone north to the Canadian border. But it was worth it. Our first substorm there was at 9 p.m. Now I have to say, we did miss the best of this. This perfect CME produced intense auroras that were for the nighttime in Europe. It was while we were still driving to Iowa during the daytime, we were seeing all these notifications of intense auroral activity and just cursing the fact that we were in the wrong time zone and it was daytime for us. But still, we saw even the dregs of this amazing storm were gorgeous. A substorm at 9, another one at midnight. Couple of videos that my husband took, and this picture on the left shows how there's actually red below the green and then again above the green. Those are two different ionized particles that give those different reds. And at 2:30 a.m., again, we had been ready to go to sleep. We actually went back to our hotel and were about to go to sleep when the GOES magnetometers started going down, down, down again. And we knew we didn't have time to get back to that lake. So we just drove out to the nearest dark farmland facing north. And as you can see, this was just this spectacular aurora filling the whole sky. Absolutely stunning. So what did I learn from all this? I think, unfortunately, I learned that I cannot cross aurora chasing off of my bucket list. I think this is one of those things that once you do it, you catch the bug and you're going to want to keep doing it. But I am very, very happy that we got to see, as you saw, 5+ auroras, each very, very different. So wonderful, each in their own way. Now, how about next year, or this year, I guess it is now, 2025. Will it be even more exciting than 2024? It may be. Solar maximum will continue, and actually, NASA is set to launch this mission Lexi this month. Lexi is specifically to study space weather. It's going to sit on the moon and get X-ray data from where the solar wind impacts the magnetosphere and try to produce better space weather prediction. I don't know that they'll be able to produce better space weather prediction in real time for auroral activity in 2025, but who knows? Maybe they'll be amazingly efficient in processing their data. I did want to add a few tips from our experience that you won't find in the Aurora Guy's beginner guide or even his advanced guide to aurora chasing. These are some things that we felt were important to keep in mind. One thing is duration. Even during the solar maximum, I think 2 weeks really will not ensure that you see, worthwhile auroral activity. And I base this on this calendar. So here we were at the absolute best time of year. We're near the equinox and we're also in solar maximum. And we saw every aurora that was on a KP 6+ night, so moderate to high activity, every single one of those we saw, except for that one where we gave up and went home because we were so exhausted. But on a 2-week trip, as you can see, you could easily get 2 weeks straight of just green and yellow. And the KP5, that's like you're barely going to be able to detect that there's maybe some flickering gray, but it's really not something people want to pay to, go on an aurora cruise for or anything like that. So it is possible to get skunked if you spend only 2 weeks. And I think a longer time makes a lot of sense. Another thing is location. To dodge the clouds, you want a central hub with fast access to a dark vista that faces north in any direction, because you don't know how the clouds will evolve, where there will suddenly be a hole opening up. Unless you're sitting under the auroral oval in Alaska or Iceland, okay, then maybe you don't have to worry as much. But even then, the clouds can be very local, right? So I think putting yourself, like some people told us that they wanted to do aurora chasing on the northern edge of Wisconsin, where it's at the south side of Lake Superior. And while that would be a fantastic aurora viewing location in some ways, you can't really escape. If there's clouds there, you can't really get to any other place quickly. Sort of fine-tuning the where and when, the darkness part, as I said, light pollution maps don't show high beams and floodlights, and also a full moon can be good. So these were kind of refinements on how to pick the optimal time and place. And forecasting as well, the NOAA KP and G number predictions, we realized systematically err on the early side. So they almost always, they will either be correct a small fraction of the time, or they will predict the auroral activity happening sooner than it really does. And as you saw on one occasion, the auroral activity was actually delayed by several days. So the best real-time info is going to come from the BZ and GOES plots, and you're really going to have to pay attention to that and just use the NOAA forecast as a very crude heads up. And finally, photography. We realized that cameras see more color, but eyes see more motion. And both the color and the dance of the lights are magical. So you really want to do some of both. Like you really just want to not spend all your time taking pictures or all your time with the naked eye, but kind of balance that to get the full wonder of it. Also, we learned that not all cell phones deliver true color. We were very lucky. We have the Google Pixel 6, which, as we learned, has sort of the best in the business of true color among cell phones. But we saw other pictures that people with iPhones were taking. And at first we were jealous because they were super brilliant color. But then we realized it wasn't actually accurate color. It wasn't what we had really seen. And so in terms of realistic pictures of what the aurora is that you saw, we were very happy with our Pixel cameras. So that's the end. This is my QR code for you if you would like to be able to go back and see my slides and get any of those helpful websites to do your own aurora chasing, then please do. And Otherwise, I am open to taking questions.
Unmute yourself if you have any questions.
Hey there, I have a question actually, back all the way when you were talking about the magnetic north. So it's my understanding that the pole actually drifts. So I'm curious if you just happen to know off the top of your head when it would be more favorable to be in Russia as opposed to North America.
So that's really interesting. I had the same question and I looked it up and it's there's actually two magnetic poles. And I'm forgetting the terminology for it, but there's the magnetic pole at the surface, and then there's the inner magnetic pole from the Earth's magnetized core. And it turns out that the magnetic pole at the surface wanders around, but it is, when you take the average of its positions, that coincides with the internal magnetic core from the Earth's molten iron. And the internal magnetic core of the Earth does not wander. And it's the internal magnetic core of the Earth that sets the poles that the aurora forms around. So in other words, the auroral oval is not wandering. It is centered on the more permanent magnetic pole.
Okay, so it will not effectively drift over to
Correct.
Russia.
Correct.
Interesting.
Yeah.
Okay.
Yeah, and I also had that same question. That's a really good question. Yeah,
Thanks.
so there's three kinds of poles. Because I only am not even an expert in this myself, so I was simplifying this by talking as if there's two magnetic poles, or sorry, as if there's two poles, the rotational pole and the magnetic pole, but there's actually three because there's the rotational pole and then there's the two kinds of magnetic pole, the internal and the surface.
Okay, and you said you didn't happen to know off the top of your head, but they do have terms for each of those?
Yes.
Okay.
I don't remember.
Yeah, I think I can probably just look it up, but thanks.
Yeah.
Any more questions?
Yeah, Sheila, thank you for the presentation. You kind of at the very beginning you talked a lot about awe, and I'm just wondering if you've seen any kind of the connections between kind of awe and almost healing. And the reason I bring this up is I came across a documentary that was called, now hold it up just for a second, but it basically had to do with kind of, I think it was like they called it the Arctic Cure, but it was some veterans with PTSD that went out and did this expedition, and they had all, suffered, very traumatic events, and just they kind of kept it more a bit adventurous, but then you got into the actual science behind what these experiences do. I mean, they're tracking, kind of logs, and they were doing biomarkers based on saliva and all kinds of stuff. So I'm just curious if, obviously, with your background in the sciences, have you kind of come across that, or did that spark anything in kind of your quote unquote chasing for awe?
Yeah, so two things. I mentioned that the experience of awe not only inspires wonder, but also humility and connectedness. And we did find that people we ran into who, actually ended up on the same lake with us, looking at the aurora with us, there was an instant camaraderie, and some of those people we've even stayed in touch with. So there's that. But and I also saw that with the total solar eclipse. Some of my friends here in the audience are people who, we really connected around that experience of awe. But there's another way I'll answer your question, which I actually wasn't going to mention, but it's so spot on that I'll just tell you something that is deeply personal, which is I retired as of July 1st, in between going to Texas for the eclipse and going to Minnesota for the Northern Lights. I retired on July 1st because I was hit really hard with two major medical conditions in the fall of 2023. And I initially I had to go on leave, but then ultimately I felt I had to retire, that it was not going to be possible for me to maintain a full-time career as a professor, even though I'm only 55. It was not going to be possible for me to maintain that career with my two independent major medical conditions. And I would say that and I did travel to the eclipse while I was still teaching, because I was able to teach with Zoom and so on. But by the time I went to Minnesota, I had retired. And I would say that experience of chasing awe and experiencing awe, it gave me a goal to fight for my own healing. And so I never missed a day of physical therapy. I never, I was so perfect about, what I ate, about, I really did everything in my power to make my body be capable of spending all this time, camping and aurora chasing and driving these long distances and being rewarded with all of these actual awe experiences of seeing the Northern Lights. I think it unaged me, like I had felt almost like, like I'm not like I was literally dying, but just like the life was draining out of me. And these awe experiences made me so excited to be alive again. So that's the best answer I can give you.
Thank you. Thank you. If anyone's interested or whatever, I put a link to that documentary, at least the IMDb one. Fantastic to watch. And there's some real science behind it. So thank you for sharing. And I got another question. Any plans to do any aurora chasing kind of in Northern Europe?
Well, so no, because we travel always with two little dogs. I think they're in one of the pictures. Let's see. Oh, you can just see one of them back there. Anyway,
Okay.
yeah, so we always have our two little dogs with us. So that kind of confines us to places where two little dogs will be allowed.
Okay. Thank you.
Anybody else have any questions? Well, Sheila, thank you very much. We appreciate it. And I am going to ask if we could adjourn for about 3 minutes and go to the business meeting after about 2 or 3 minutes. We'll come back and do the business meeting. We won't hang out as long as we normally do. We'll be right back.
Thank you.
Thanks, Sheila.
Thank you all for coming.
Thank you.
Thank you.
Outstanding presentation, very interesting.
We're off the recording now, yes?
No, we let the recording, so we record the business meeting.
Oh, okay. Well, just without going into the details, in a similar boat right now, Sheila, and the awe part is something I am just thoroughly engrossed in, and I really would encourage folks to follow up the stuff from Michael because they're doing some heavy research on this. I'm a former psychologist, and it's something that's been fascinating to me as well in terms of how this impacts on recoveries. So thank you for the personal share as well.
So I'm going to wait until about 8:48 and then start, if that's okay with everybody.
I don't need to stay.
Not unless you want to.
Not unless you want to hang out for a business meeting. Nice.
I will say one thing. I noticed again. This is all just based on that documentary. And it's not just a one-time deal where it's like, oh, I go see this amazing awe, and I'm overcome by something. It's what they wind up recommending. Not to spoiler alert, I guess. But it's something that you had to continue to do. It needs to be a pattern of life. So. I think they may recommend it's like try, you don't have to go do a whole trip up to the Arctic, every 2 weeks, but just go do something, commune with nature, do something to get out of your head. And they said, yeah, if you do it every 2 weeks, that healing continues.
I'm going to check out that documentary. Thank you.